Hey everyone, this is Jesse Kavarvix. A few weeks ago I joined a 3D printing group on Facebook and found out that they were holding a design competition. This design competition is to design and 3D print a foam dart launcher. Basically any machine or contraption that will launch these small or large or round Nerf darts. Basically this video is my submission to that contest. Now, anybody that knows me or has heard of me knows that I have a little bit of a leg up in this game. And that is because I designed this. This is the FDL-1. The FDL-1 is arguably the world's first fully 3D printed Nerf dart blaster. Not only, like I said, is the entire thing 3D printed, but it is also robotic and it is controlled by a microcontroller very similar to the Arduino. Now, we won't talk a huge amount about the FDL-1, but I will make comparisons to my submission for the sake of transparency of the contest. So, without further ado, I'd like to introduce you to the FDL-2. So the FDL-2 is basically the FDL-1's baby brother. Not only is the FDL-2 designed to shoot these small size Nerf darts as opposed to the mega size darts that the FDL-1 is designed to fire, it is also designed to accept stock Nerf magazines like this. So the magazine would slide into here, and then there is a button on the bottom that you push in order to pull the magazine out. Now, the FDL-1 is designed as a revolver style blaster. So if we look at it, that means the darts load into the revolver like this, and then the revolver spins, and then there are a pair of flywheels in the front that hurl the dart out once a pusher mechanism in the back of the blaster pushes it through the flywheels. The FDL-2 has that same basic flywheel design, except this time around there is no revolver. That means the FDL-2 is considerably less complex than the FDL-1. Alright, so let's take a close-up look at the FDL-2. Just like the FDL-1, the FDL-2 uses brushless outrunner motors to propel the foam darts forward. A lot of regular Nerf blasters actually use brushed motors, and that's fine, and they work very well, and some of them are actually extremely powerful. I actually went with the brushless motors mostly because I had them kicking around. I have a drone that I had gotten a couple years ago, so I tried taking the motors off of it and putting it on the FDL-1, and it worked really, really well, and it shoots the large darts very hard. So I figured it'd be really neat to try taking those same brushless motors and putting them on a blaster designed to shoot the smaller darts, which are actually about half the weight of a mega-sized dart. So in the back of the FDL-2, and I actually 3D printed these little thumb screws in order to open up the case. So if you open up the cover, you can start seeing what's inside the FDL-2. So we talked about the motors on the front that actually propel the darts, but there is a second major part of the operation of the FDL-2 and also the FDL-1, and that is actually physically pushing the dart into the flywheels so that they can hurl the dart forward. For the FDL-1 and also on the FDL-2, I have chosen to use stepper motors. Now, those of us that come from the 3D printing community know exactly what stepper motors are, and that is exactly why I use them. The FDL-1 was basically a culmination of all the cool hobbies that I've had over time, just compiled into one really cool robotics and 3D printing project. So I've carried that same mechanism over into the FDL-2. So as you can see, there is a stepper motor right here. There is the stepper driver right in front of it, and then on the back you can see the microcontroller. The microcontroller that I used in the FDL-1 is actually a particle photon microcontroller. I really like the photons because they have Wi-Fi built directly into them, which means every time I want to reprogram the FDL-2, I don't have to plug a wire into it. I can just flash it over the air. So in terms of the stepper motor, what I really like about stepper motors is their precision and the ease that I can make them turn both directions, and also one really interesting thing. If you try to turn a stepper motor and it doesn't have enough torque to move whatever you're trying to turn, it'll actually slip. Normally this is a really bad thing. Like if that happened on a 3D print, your print would get shifted and you would end up with a scrap print. I actually like using that feature of a stepper motor because what I can do is build a little logic into the FDL-2 so that it knows when it's actually jammed. So the mechanism that pushes these darts looks like this. So you have your stepper motor, and then you have kind of a round spinner piece that slides onto the end of the stepper motor. So this is inside of here like this. And then you have this kind of T-shaped pusher, and then you have a rod on the back of the spinner, and then as the stepper turns, it turns rotational motion into linear motion. Now, when this pusher reaches the back of its arc, you can see there's actually a green wire here, and that is because there is a homing switch in the back of the FDL-2 as well. The same thing exists on the FDL-1. So what the homing switch does is tells the FDL-1 when that pusher mechanism is all the way back. It's important for the FDL-2 to understand when that happens for a couple of reasons. First off, the pusher is out of the way of any darts that are being fed up through the magazine. That way the FDL-2 knows when it's ready to fire, and if it's not in that kind of home position, it knows that there may be something wrong, and it may try to take some action to get itself out of it. The other reason is if you put the magazine in, and then the pusher spins but ends up left halfway out, you actually couldn't get the magazine out because the pusher is designed to very accurately fit in the channel provided on a Nerf magazine. So we talked about the stepper motor. Inside the front of here, there is actually a bunch of wires bundled up, but there are two electronic speed controllers. So the brushless motors need to be powered by speed controllers, which is what makes them a little different from regular brushed motors. So what happens is there is what's called a PWM data feed from the microcontroller in the back to the speed controllers, and then the speed controllers obviously control how fast the motors in the front spin. The speed controllers actually act very similar to what a servo might act like, and the control between the microcontroller and the speed controllers is actually identical between a servo and a speed controller. It actually makes it way easier than most people think to power brushless motors with an Arduino. On the side of the FDL-2 there are a few knobs. Very similar to the FDL-1, except the FDL-1 has one knob. The one knob on the FDL-1 controls the speed of the flywheels up front. That way, if you're using the FDL-1 or also the FDL-2 inside or around children, or just in a situation where you don't want to shoot it super hard, you can turn it down and very gently lob darts out of the front. Alternately, you can turn it all the way up to 11 and launch darts extremely, extremely hard. So this front knob on the FDL-2 is something completely new to the FDL-1. Now the FDL-1, the revolver action actually takes a decent amount of time to do, so you can't get a huge rate of fire out of the FDL-1. I equate the FDL-1 basically to a hand cannon. It's not so much how fast you can shoot the darts, but just that the darts are bigger. Bigger is better. So on the FDL-2, because there is no revolver mechanism, we can actually rapid fire considerably faster than the FDL-1. The FDL-2 I actually stopped using as fine of a microstep on the stepper controller as well, and was able to get it to spin a little faster. So this switch in the front controls the mode that the gun shoots at. And we will talk about this in a minute. I'm going to get up and I'll do a firing demo, but real quick while we're looking at it. This lever is actually what's called a select fire lever. So if it is all the way down in this position, when you pull the trigger, it'll only fire once. And as long as you hold the trigger down, it'll only fire once, it won't fire again. If you turn this up one notch, it will fire twice. So you pull the trigger, the FDL-2 fires twice, and not until you pull the trigger again will it fire again. Similarly with the next notch, it fires 3 darts. 3 darts is a pretty common what's called burst mode for foam dart blasters. I actually really wanted to include 2 because as you'll see the FDL-2 goes through ammo pretty quick, and I wanted an option that wasn't going to chew through ammo quite so fast. And then of course the very last notch on this selector is completely full auto. So as long as you're holding down the trigger button, it will just keep firing over and over and over regardless of whether you have darts left or not. This knob in the back is what would appear to be a rate of fire knob. Again, we'll look at this in a minute when I get up and actually fire the FDL-2. So what this will effectively do is slow down how fast the FDL-2 will fire from dart to dart. Now, it's a funny thing because the FDL-2 is using a stepper motor. So what this knob is actually doing is controlling the acceleration of that stepper motor. Now, the only problem with stepper motors over brushed motors is that the faster that they spin, the less torque that they can provide. And as I mentioned before, if the torque that the motor can provide is not enough, the motor will slip and it won't turn. So what the common practice is with a stepper motor is actually to accelerate from a slow speed to a fast speed. And in doing so, you maintain a lot of the torque that the motor has up until the point where you are traveling considerably faster. So what this knob is actually doing is adjusting how fast the FDL-2 accelerates from this pusher being all the way back to all the way forward. Once it's all the way forward, there theoretically shouldn't be a dart in its way, so it can move very fast back to the starting position. So if you turn the knob all the way down, it's going to accelerate very slow, which actually means that you get more torque out of the motor. So if you have darts that are a little hard to push out of the magazine, that is how you would get the blaster to push them out. You can continue to dial that knob up and up and up to the point where the motor actually starts to slip, dial it back just a little bit, and that is as fast as you can fire the gun. It's actually pretty fast. So let me actually put this cover back on, and I want to show you a couple things before I get up and do a firing demo. The FDL-2 is actually powered by a lithium polymer battery. Again, this is another thing that came from the drone world and is widely used in the Nerf world as well. So what I've designed is this kind of clamshell mechanism in order to open the handle guard up and allow you to access the battery. And then as you can see, the battery actually slides into the handle of the gun. This makes it fairly easy to get the battery in and out and gives you fairly easy access to the charging cable on the battery. Alright, so let's get to the fun part, and that's shooting some darts. So I've gone ahead and I've loaded up a 12 dart Nerf magazine. This particular magazine and a number of others that I've seen have one side that is a translucent plastic. So I actually left a window in the side of the mag well here so that when you slide the clip in, you can actually see how many darts you have left in the clip. So actually one of my favorite parts of the FDL-2 and the FDL-1 as well is how it sounds not only when you boot it up, but also when the flywheels spin. So that sounds like this. Just really neat. It kind of makes the thing a little more robotic feeling. Now let's go through some of the features that I talked about before, but this time you'll kind of see them in action. So again, on the side of here, this is your speed knob. So that controls how fast the flywheels spin, thus how fast the dart would spin. So if I was to turn it down, they spin fairly slow. If I turn it up, they spin a whole lot faster. Now, the knob on the front, like I mentioned before as well, is the select fire knob. So all the way down is 1 shot, the next slot is 2, the next spot is 3, and then all the way up is full auto. So I'm going to turn the speed of the FDL-2 up about halfway, and then put it on the single fire mode. It looks a little like this. So now that I think about it too, the FDL-2 and the FDL-1 both operate a little bit differently than most flywheel Nerf blasters work. So most flywheel blasters actually have 2 buttons on them. One, when you pull it, it spins the flywheels, and then the next button, because a lot of other blasters don't have this kind of robotic control to them, the trigger is actually just a mechanical mechanism that pushes the pusher and then thus pushes the dart out of the gun. The FDL-2, because it has the microcontroller in it and because everything is operated electronically, you really don't need that whole mechanism. And then the microcontroller can just kind of go through a sequence of actions in order to fire the gun. Thus, the FDL-2 only has 1 button on it. All you have to do is pull the button and it'll shoot. It knows approximately how long it has to spin the motors up because they're fairly precise and they're very consistent. So it knows it's 200 milliseconds or 300 or whatever the prime number is. So beyond that, let's go through the different modes. I'll turn it up 1 notch and then we do 2 shots at a time. The third one, 3 shots. And then all the way up would be full auto. So let's build up a bigger clip and play with the full auto a little bit. Alright, so I've gone ahead and I filled up a 35 round Nerf drum. This is arguably the best way to use an FDL-2 because it does chew through so many darts so fast if you choose to use it in a full auto mode. The 35 darts will give us a little bit of room to play with so I can talk about a couple things. Now, actually, before we get too far in the full auto thing, there is one other thing that I did a little different between the FDL-1 and the FDL-2. The FDL-1, when you pull the trigger, you have a period of time where those flywheels spin up, and then the pusher mechanism pushes the dart. Every time you pull the trigger, that amount is exactly the same. And it also takes into account how long a revolver has to spin and whatnot. Obviously there's no revolver on the FDL-2, not a big deal, but I did work one thing in. So one thing I thought about, if you can only shoot 1 shot at a time in the single fire mode, what you really want to be able to do is get that full spin up on your first shot, and then your successive shots after that, because the motors are already spinning, they really don't have to spin up for so long. So there's actually a period of cooldown after you fire a shot that the FDL-2 won't take as long to spin up. So if you watch, that's the full spin up. If we then shot 1 and then a couple right after it, the spin up each time is less. So that way you can continue to shoot at different targets in the single fire mode. So that would be a little like this. Now the same thing works in dual fire, triple fire, and full auto as well. Now I did want to talk about this back knob a little bit. Like I explained before, it actually adjusts how fast the stepper motor on the pusher mechanism accelerates. So effectively, if you turn that all the way down, your full auto is a little slower. Now if you have some darts that are a little harder to push out, maybe they're brand new or something, you may want to turn it down a little slower because it's getting more torque. But then you could turn it further up, it's not accelerating as fast, it's more full speed. and you get more of a full auto sort of effect. Alright, so that's about it. I think I covered just about all the features on the FDL-2. I've shown it off a little bit. So let's just take it through its paces a little bit. Let's crank it up a little higher, and I'll come in a little closer and we'll see what true full auto through an entire drum looks like. I think that's pretty sweet. So thanks for watching this video. This contest has actually been really, really cool. It's cool that not only is this kind of my thing, and there's a contest for it, but it's also introducing the world of Nerf into the 3D printing community and the 3D printing community to the Nerf community. It's a cool combination of different communities all together at once. Not only that, but I know that the design skill in the 3D printing community is pretty high, and I am really excited not only to submit the FDL-2, but also to see what other people come up with. At stake in the contest is an Ultimaker 2 Plus 3D printer, which I use PrinterBot printers right now, which are great budget printers, but the Ultimaker 2 would be a really cool, nice, higher quality printer to use. So if you would, please go to the FDL-1 Facebook page, like that page, and then you will get updates about when I officially release the FDL-2, either for sale or the design out into the public, and then also further updates on both the FDL-1 and FDL-2. You can also go to FDL1.com, and I have basically all of the information culminated together in one spot. There are links to the Facebook page, the FDL-1 Thingiverse page. The FDL-2 will eventually be on Thingiverse. For the contest, I need to submit the STL files for the FDL to umagine.com. I will put that link in this video and also on the Facebook page. So if you go like the Facebook page, you can get to that link. So thank you for watching, and like I said, go like the Facebook page, follow me on Twitter, Facebook, wherever you can find me, to keep an eye out for the FDL-1 and the FDL-2 and what other FDLs come in the future. So thank you again.